This is the topic of solving simultaneous equations in the case when we are given with a linear and a quadratic equation. So the method is that from the linear equation we need to substitute this into the quadratic equation and then solve. We would be getting two values of the one of the variables, and then corresponding to that, when we would replace back that values into this equation, we would be getting two values of the other variable. So our ultimate goal would be to find a pair of the points x1, y1 and x2, y2. So this is what is going to be done in this question. Okay, let me start. Let me call this as equation number 1 and this as equation number 2. So I say substituting equation number 1 in equation number 2. What do we get? At the place of y, I'm going to replace x plus 3 equals to x squared plus 5x minus 2. What I have done actually that at the place of this y, I have replaced this value over here. So now you see there is no y here. The variable y has been eliminated. Now this whole equation is containing only one variable, that is x. And this is a quadratic equation in the variable x. So we just need to solve this quadratic equation in x in either of the methods. Either we can apply the factorization method or the completing square, or we can apply the quadratic formula. And this will give us now two values of the variable x, x1 and x2. Then what we will do, we would be substituting x1 into this equation number 1. That will give us value y1, and as a whole I would be having the point x1, y1. And then this x2 is going to be replaced in the same equation 1. That would give me another value of the variable y, that is known as y2, and as a result I would be getting my required point x2, y2 as was required. So this is the algorithm. Now let me follow it over here. Now in this case, what I need to do is x squared plus 5x. Let me shift both of these terms to the other side. So this would become negative x, and negative 2 is already on one side of the equality. When I will shift this positive 3 to the other side, it will get subtracted. So this will give me negative 3. Now only one term of x squared, then simplifying 5x and negative x, that will give us plus 4x and then minus 5 equals to 0. Now this is the quadratic equation in the variable x. Now I can simplify it uh, using any of the methods. Now let me try using the factorization method. That is also known as middle term breaking method. Okay. X squared would be the same. I need to have the factors of negative 5, which are obviously 1 and 5. So I would be doing it negative x and positive 5x, and then this negative 5 would be the same, equal to 0. Only thing that has been done is actually the factorization that has been done, or you can say the middle term 4x has been broken down into two terms, negative x and positive 5x. Now we need to just group them. The first two terms and the last two terms can be combined together. That would give me, if I take common from these two terms, the variable x can be taken as common. So from the first term, we are left with only 1x, minus from this second term, I'm left with just 1. Okay, same goes with the other pair. 5 can be taken as a common factor. From this term, I'm left with only x, and negative is there. And from this 5, I'm left with 1. And on the right side, there is 0. So this would be the same. Okay. What's the benefit of doing like this is that we have got x minus 1 as a common factor again. So we can take it out as a common factor once again, x minus 1. So from the first term, I'm left with x, and from the second term, I'm left with 5. So I can write it down like x plus 5 equals to 0. Now you see, uh, we have factorized this equation in this format. Now this says that the product of two factors is 0. There is a rule that if the product of two factors a and b is equal to 0, that gives either the one factor a is equal to 0 or the other b is equal to 0. So that's what I'm going to apply here. Either x minus 1 equals to 0. So that will give me x is equal to 1. Or the other factor x plus 5 equals to 0, and that will yield x equals to negative 5. So we are done here up till here. We have got two values of the variables x. As I told you, we use this factorization method, then we have got two values of the variable x. Now we would follow this step. We would be substituting these values of x into the equation number 1. So let me solve it here. So equation number 1 becomes, for x equals to 1, I'm replacing this value first. So that will give me y equals to x plus 3. That is 1 plus 3. That is equal to 4. That means the value of the variable y is 4. So I've got this value. So now I just need to write it down in the form of a point. the point would be the value of x is 1, comma, the value of y is 4. So 1, comma 4 is my this point. I've got this thing. Then I need to solve for other values of y, substituting x equals to negative 5 now. I'm following this step now. I would be substituting x2 to get y2. So equation number 1 becomes for x equals to negative 5, y equals to x plus 3. Okay, so I'm going to replace this value, negative 5 plus 3, which is negative 2. So the value of y is negative 2. I've got this value. So now I need to write it down in the point form like x2 comma y2. So the point is negative 5 and then negative 2. So these are our two required points and the equation has been solved. So this one and this one. That completes this solution of the question. Now let's do another question for another practice. Let me take, for example, uh, part C of question number 2. Now, this is equation number 1, the linear one. This is second equation, the quadratic one. So, I'm going to adopt the same procedure from equation number 1. We need to replace the value of any variable. Let me have x equals to 5 minus y. Let's replace the value of variable x this time, substituting in equation number 2. So that would give me x squared plus y squared equals to 13. So this value of x would be replaced or substituted here. So simplifying it, 5 minus y, that is the value of this x, and then its whole square like this, plus y squared equals to 13. Now here I need to apply the identity a minus b whole squared, that is a squared minus 2ab plus b squared. So this will give me now 5 squared minus 2 times 5 times y plus y squared, and then plus y squared, this one equals to 13. Now we need to simplify them. 25 minus 10y plus y squared plus y squared, that is 2y squared. And let me shift this 13 to this side, that will give me negative 13. So 2y squared minus 10y and 25 minus 13. Now you see, in all of these terms, we have got 2 as a common factor. So we can take 2 common, 2 taken common, y squared minus 5y plus 6 equals to 0. And this 2 gets divided here with 0. So that will give me 0 by 2, that is 0. So that is my equation, the quadratic equation, which we need to simplify now. Uh, Let me adopt that factorization method. So I need to have the factors of 6. Uh, I can have either the factors of 6 to be, factors of 6 could be 6 and 1 or 2 and 3. We need to choose that pair which could uh, give us the middle term, and the product should be giving us 6. So the factors would be y squared minus 2y minus 3y plus 6 equals to 0. Now I need to just pair them up, this pair and this pair, taking out something common, that is y can be taken common from this and this. So from the first term I'm left with y, and from the second term I'm left with negative 2. And from the second term now 3 can be taken as a common factor, and y and minus 2. You need to be very vigilant since there was a negative sign here. So this positive sign has been changed to negative. Now altogether y minus 2 is a common factor. So we can take it out as a common factor. From the first term, now we are left with just with this y, and negative 3 from this second term equals to 0. So now that will again give me y minus 2 equals to 0, which will yield y equals to 2. And then also y minus 3 equals to 0, which will give us y equals to 3. So now our final point is uh, achieved by substituting these values of y into this equation. When y equals to 2, then x equals to 5 minus y, that is 5 minus 2, that is 3. So the point is 3 comma 2. And when y is equal to this, then x is equal to 5 minus y will give me 5 minus 3, that is 2. So the point is 2 comma 3. One is this solution and the other is this solution. So that's it. That's how we do these questions involving simultaneous equations, given that one is a linear equation and the other one is a quadratic. So we have solved part C. That's also of the same format. One equation is linear and the other one is a quadratic. That has given us two solutions in the form of points, this one and this one. So that's it.